Hey everyone, and welcome. So let's just dive right in. I want you to imagine you have a bag full of Scrabble tiles. You can shake them up, right? The order is totally random. You can peek inside to see what letters you have, but you can't have two Q tiles. You only get one of each unique letter. And that, right there, is pretty much the whole idea behind a Python set. It's like a little bag for your unique items, where the order just doesn't matter. So think about this common problem. Imagine you've got this huge, messy list of data, maybe thousands of usernames or product IDs, and it is just full of duplicates. How do you clean it up and get just the unique entries? Well, you could write a pretty gnarly loop, or you could use a set. And today, we're going to see just how incredibly simple sets make this exact problem. So here's what we're going to cover. First, we'll get down to the basics of what a set actually is. Then we're going to get our hands dirty and create some, see how to mess with them. And then, this is the fun part, we'll unlock their real power with set operations. And finally, we'll wrap it all up with why this is going to be so useful in your own code. Let's get to it. All right, first up, what is a Python set, really? Let's get the official definition down so we're all on the same page. And there it is. A set is an unordered collection of unique elements. You really just need to remember two key words here: unordered and unique. Unlike a list, the items in a set don't have a number, no index, no specific position. And, like we said, anytime you try to add a duplicate, the set just ignores it. Okay, so let's tick off these core properties. First up, they're unordered. You can't ask for the first item because there isn't one. Next, they are mutable, which is just a fancy way of saying you can change them. Add stuff, remove stuff, no problem. Their absolute superpower is enforcing uniqueness, which we'll see in action in a sec. And when you see them in code, you'll know them by those curly braces. All right, enough theory, right? Let's actually write some code. It's time to create our very first sets, and I'm also going to show you a super common pitfall you'll want to avoid. And boom, this is how we solve that problem from the beginning. Look at this. We start with a list, S3, and it's got a duplicate 2 in there. Then we just pass that list to the set function. It's like magic. Python just automatically tosses out that extra 2, and what we're left with, S4, is a clean set with only the unique numbers. It's really that easy. Okay, here is a huge pro tip, a classic gotcha that trips up so many people when they're starting out. If you type empty curly braces, you'd think you're making an empty set, right? Nope. You can see right here, Python actually gives you an empty dictionary. It's a historical thing. So to make a truly empty set, you have to explicitly call the set function with nothing inside. Remember that one. Okay, so we know how to make a set. Now, what can we actually do with it? Let's go over the basic toolkit for checking what's inside and making changes. The basics are super simple. You can check if something is in a set with the in keyword, and this is incredibly fast. To add something new, you use the .add method, and hey, notice how the order gets all jumbled up when we add 100? That's that unordered property for you. To get rid of an item, you use .remove, and if you want to just wipe the whole thing out, .clear gives you a fresh empty set. Easy peasy. And now we get to the really cool part. This is where sets absolutely shine. Making and changing them is one thing, but the real power, the reason you want to use them, comes from these powerful mathematical operations you can perform. This is where they become a serious tool for data analysis. A union is super simple. It just combines two sets into one. You get a brand new set that has every single unique item from the first set or the second set or, well, both. It's basically like taking two piles of stuff and just smushing them together into one big pile, with no duplicates, of course. And here's how you do it. You can totally use the union method, and it works great, but honestly, the pro way, the shorthand, is just using that vertical bar or pipe operator. Look at that. S1, while S2, so clean. Both get you the exact same result, one big set with all the unique numbers from both S1 and S2. Next up, intersection. So if union is all about everything, intersection is all about the overlap. It finds what's in common. When you do an intersection, you get a new set with only the elements that exist in both of the original sets. This is perfect for finding where two groups of data meet. So in this example, what numbers do S1 and S2 have in common? Well, it's just 3 and 4. So their intersection is a set containing just those two numbers. Again, you can use the .intersection method, or you can use the much shorter and, let's be honest, cooler looking ampersand operator.
Now for the difference. And with this one, you got to pay attention to the order because it matters. The difference of A and B gives you everything that's in set A, but not the stuff that's also in set B. It's like saying, give me what's unique to this first group and throw away any overlap. Let's look at the code. We ask for A minus B. So we start with everything in A, which is 1, 2, 3, 4, and then we remove anything that's also in B. Well, B has 3 and 4, so we get rid of those, and we're left with just 1 and 2. The dot difference method works, but come on, the minus sign operator here is just so much more intuitive.
And our final operation is the symmetric difference. It sounds a little complicated, but the idea is simple. Think of this as the anti-intersection. It gives you a set of everything that is in one set or the other, but specifically not in both. It's all the elements that are not shared between them. So here, we're basically throwing away the common elements, the 3 and 4, and keeping everything else. We keep the 1 and 2 from S1 and the 5 and 6 from S2. The result is a new set with all the unique, non-overlapping parts. The method name is a mouthful, symmetric underscore difference, but the operator is just that little caret symbol. Super handy.
Whew, we've covered a ton of ground, from making sets to slicing and dicing them with these powerful operations. So let's bring it all home. Let's talk about the why. Why should you even care about using sets in your code? So here are the key takeaways. First off, speed. They are ridiculously fast. Checking if an item is in a set is way, way faster than searching through a long list. Second, uniqueness. It's the cleanest, simplest, most Pythonic way to deduplicate any list or sequence. Just turn it into a set. Done. And finally, data logic. All those operations we just saw, they are perfect for real-world problems, like finding users who are in Group A but not in Group B. It's a game changer for data comparison. And that's a wrap. We've seen that sets are way more than just another data type. They're a specialized tool for handling uniqueness and comparing groups of things with amazing speed and clarity. So I'll leave you with this. Now that you have this tool in your toolkit, where in your own projects could you unleash the power of sets? Thanks for tuning in.